General relativity, step by step. I've got this beautiful Kruskal diagram here, and there's one feature of it which I've not really mentioned yet, which is this triangular region here. Of course, it's infinite in all directions, so a triangular region here. What does this correspond to here? Well, if we look at these regions, you normally call this region 1 and region 2. If you talk about 1 and 2, 1 and, I guess you call it the union of 2, cover the whole of R, not quite the whole of RT space, R greater than 0 and T. That's Schwarzschild coordinates. The whole of space-time, R, T, is covered by these two patches here. So in one sense, these points here don't correspond to anything because they don't correspond to any point in the Schwarzschild space, in Schwarzschild space-time. So what do they mean? What does it mean? Well, it's not altogether clear. One thing you can do to try and understand that is to take this coordinate system here, and you'll see that I've put the orange and the green lines and so forth, and light and whatever, and try to extend it analytically on this side of the event horizon. And you can do that, and you get these things called extended Kruskal coordinates. And I've got a picture here. Just a minute. There we go. And what I've done here is I've done just as I said. I've taken the coordinate system and I've just extended it across here, and across here, and so everything's a nice continuous map. You normally call this region 1, region 2, region 1 dash, and I'll just get rid of this lot here, region 2 dash. Sometimes you call this the universe. This bit here is the black hole. This bit here is the anti-universe. And this here is called a white hole. I'll talk about the white hole first. The white hole, again, if you look at light beams, they go outwards. Nothing can come back in. This is an inverse of a black hole. Here, light beams eventually find R is less than 0. Here, the light beams are constrained to move away from R equals 0. So it's a rather peculiar object, and of course we have seen this before. We saw it in the Eddington outgoing coordinates, where the light cones are tilted away from the origin. So we have seen this before, and this space-time solution here corresponds to the white hole of the Kruskal extended coordinates here. Let me just get rid of these things here. Well, the white hole's great. Do they exist? Well, depends what you mean by exist, really. Let's talk about the universe and the anti-universe. The first point to observe is you can't travel to the anti-universe. Let's just say that you're sitting here at some point in space, time, and you think to yourself you want to travel to a point in the anti-universe out here. Well, there's absolutely no way you can do that because you have to travel faster than light. This is a space-like trajectory, not a time-like trajectory. You simply cannot travel from the universe to the anti-universe if you're constrained to go less than the speed of light, which is a bit of a shame, really. Of course, once you're inside this region here, you can't get out of it, so that's it. Yeah, that's a shame. But you can do this. Here's an event here, and there's its world line falling in here. Here's an event in the anti-universe, and that's that world line here. Look, they cross here. Now, does this correspond to anything that might happen physically? Well, nobody seems to know. And of course, even if you're crazy enough to throw yourself into a black hole to see if you see anybody from the anti-universe, you may or may not see someone. But if you do, you can't get a message out to our universe, or for that matter to the anti-universe, to tell anybody about it, because you're trapped inside the black hole. So you've got this knowledge, and you take this knowledge to your grave, to the singularity, which is a bit of a shame. So this is quite an intriguing mathematical prediction that there exists a whole anti-universe. I hesitate to say behind, but in some senses connected to our own universe, in some sense through a black hole, which is a rather tantalising prospect. There's no consensus on whether this is real or a mathematical trick, and I've been thinking about this for a long time, and I simply don't know. On Monday and Wednesday and Friday, I think to myself, no, it's just a mathematical trick. On Tuesday, Thursday, and Saturday, I think to myself, No, it really must exist because the math says it exists, and on Sunday I don't know. So there's this rather peculiar anti-universe sitting out here that may or may not exist. That's a pure mathematical prediction. Yeah, quite astonishing. I'm going to stop there. Stop.